So welcome to this webinar on critical chain applied to the biomedical industry, how to develop your products for tomorrow faster. The agenda is very simple, an introduction, briefly what's specific about the biomedical industry, but since having looked at who's joining us, then nearly everyone is in the biomedical industry. We'll do that very quickly just to get everybody on the same page. Then we'll look at critical chain project management of a single project and do some case studies. There'll be 4 or 5 different case studies from different companies in this webinar. And once we've done the single project, then we'll look at portfolio management, again in the biomedical industry, and conclude. My name is Philip Marris. I'm English but also European, work that one out. We're based in Paris, France, and I'm bilingual, bicultural, French and English. Historically, chronologically, I started way back in 1984. I first learned what we call lean today. At the time, it wasn't called that. And just a bit later, I started working with Eliel Goldratt, the founder of the Theory of Constraints, back in 1986. So basically, my career has been mixing in theory of constraints and lean in all kinds of industries ever since, right? As you'll see in a second when I show you the kind of companies we've worked with. I've been doing this a long time, so I've done it over 350 times throughout the world in, I've stopped counting the number of countries, 60 countries, something like that. I'm the author of a very boring French reference books on theory of constraints. You don't have to read it for today. It's all about theory of constraints applied to manufacturing, so it's not specifically interesting necessarily for what we're talking about today. Anyway, and I founded nearly 20 years ago now Marris Consulting, based in Paris, France. Okay, what we do in project management, it's about half our work, half our assignments, and so we've done now over 90 implementations of critical chain project management. And there are, in Marris Consulting, there are 16 consultants now and a network of partners. We do give a lot of conferences or webinars like this one, over one a week. Also, if you don't know it, we have a very rich YouTube channel, Marris Consulting, which has over 500 videos, over 600,000 views. I'll refer to it a number of times because you can catch up on other stuff in that. And also worth mentioning that there is an online course on critical chain project management that we developed and launched last year, so it's all fresh and new and talks about all these things. Okay, we're kind of hard to identify as a company in where we work and where we don't, because we're very curious and we try and work basically everywhere where there is a physical product. Okay, so you know, in transport, that's everything from a bicycle, a motorbike, a car, a train, a plane, a rocket, but then it can also be fast food, it can be luxury goods like expensive handbags, it can be pharmaceutical and biomedical, which is what we're going to be talking about today. I guess that's about 20%, I guess, or maybe 25% of our business is in pharmaceuticals and medical devices. You've got some of the names there, and it can be food, it can be chips you eat, it can be chips you put in your computer, and all sorts of other stuff, as you can see. Over 350 different organizations throughout the world. It's about, at the moment, it's between 60 and 70% of our work is outside of France, where we're based. So it's really all over the world, from Vietnam to California to Finland to South Africa. Anyway, all over. And so that's what we're basing our experience on, and of course today the biomedical side. Okay. I'm going to talk about applying the critical chain in biomedical. I won't have the time in this short format to go into the details of what is the critical chain approach. Okay, so for those who don't know it or don't know it well, or after this webinar want to learn more, okay, there are plenty of free resources to do that. Probably the best thing, if you really want to understand what's this approach, is the series of 4 videos you can see there, critical chain training 1, 2, 3, 4. They're each about 20 minutes long, so in a bit more than an hour, you really get I hope, a detailed, good explanation of what the approach is right from the beginning to the end. Okay, and if you want to know more, there's the Critical Chain website that we run and administer called criticalchainprojects.com. That's also bilingual French-English, by the way. And then there's on our YouTube channel with 500 videos, there are at least 100 of them deal with critical chain. They're by ourselves, by our clients, lots of different formats. Have a look. Okay, so forgive me if I won't spend too much time explaining what the approach is. I'll try and give you an executive summary, but if you want to learn more, please do have a look at these other resources, right? Because it's I'm going to have to go very fast on exactly how it works. Okay. So what's specific to the biomedical industry? Well, as I say, if I checked who's participating, and not surprisingly, most of you are from biomedical, so I won't go waste your time telling you you're the industry you're already working in. What is it? Well, it's quite diverse, isn't it, in terms of the product. It can go from simple surgical masks to very sophisticated diagnostics systems, and you'll see some of those more sophisticated things in the case studies we're presenting later on. But it can also be, just a surgical mask, or many other things. Okay, and like many businesses, it's not unique at all. Obviously, the speed with which you develop products is important, and there's always pressure to develop them faster and faster. Okay, and you do this in a highly regulated industry with the FDA, the European equivalents, and another country geographical entities that have to give you the right to operate, right? The right to sell your products, right? You have to get their approval. So this is a significant aspect of the work one does. Okay, it's not the only one. I mean, aeronautics also has its rules and regulations, but it's true that it is an important element of biomedicals, especially as, for instance, at the moment in these past few years, they changed the regulations. For instance, in the European domain in biomedicals, putting up the bar, according to some people, way above what was reasonable. But anyway, that's maybe there'll be some questions about that. It's a challenge when the rules change, right? Anyway, what are the phases of biomedical project development? Well, the vocabulary varies from one geography to another. It's not exactly the same words and presentation between the USA and in Germany or whatever. So I won't bore you with the kind of details. Okay, but we just agreed that there are various steps from the initial idea of the product, and then you have to check that it works correctly and get validation, and that's the developing of a new product. But of course, that's just one aspect of what one is doing. Very often, one is also producing the same product for different geographies and therefore different regulations, and therefore you're going to do one product, but it's going to have the version for the FDA and the version for Europe, that sort of stuff. And also, you can transfer products from one geography to another, from one factory to another, and all these sorts of things, and all that's involved in managing projects in the biomedical, right? Okay, now just in case you don't know of it, for the pharmaceutical industry, not specifically biomedical, but it's very close, there is a fun little novel called Be Fast or Be Gone by Andreas Scherer. It's a few years old now. I guess it's maybe 10 years old, and it's in the form of a novel, because for those who don't know, the theory of constraints has sort of fell in love with the format of a novel ever since Eliel Goldratt wrote the novel The Goal, the business novel The Goal, which is a global bestseller with now 10 million copies sold, 32 languages and so forth, right? Which presents the theory of constraints in manufacturing. There's another one called Critical Chain, which presents the ideas of critical chain. And here there is one specifically about applying critical chain in a pharmaceutical company, and it's a novel, right? So it's the heroes saves his own son who's got a disease that can only be prevented or cured, by developing a new drug, and so he develops a new drug using critical chain much faster and saves his son. And afterwards, then the second half of the book, he applies the critical chain to portfolios, because again, you'll see it as I go through. There are two dimensions to critical chain. One is a single project, and the other one is a portfolio. Okay, so what is critical chain? Well, that thing there is an iconic fever chart, right, with the three colors. How does it work? Well, let's take a very simple example of a project. I'll give you here a mechanical object as an example, but I could have taken a medical devices. It's just there would be more complexity. So I'm keeping this one very simple at this stage. Let's assume one's developing a new engine that works on water. Okay, and to do that, we first have to prove the concept that we have imagined. Okay, and so in this example, let's imagine that I went to see the person who does the proof of concept in my company, and I asked him, how long will it take you to prove the concept that we have here of an engine that works with water? And they look out the window and think of it, and they say give you 4 weeks, which is what they often give you for that kind of question. Okay, you go to the next head of department who does the prototypes, and you say, hey, if I bring you this prototype here in 4 weeks' time, how long is it going to take you to do the prototype? To impress his boss, he uses Excel, does a few simulations and stuff, and says 16 weeks, which is often the answer he gives anyway. And then he goes on to the next guy down who has to do the prototype, and he says, if I bring you this in 20 weeks' time, how long will it take you to do the prototype? The guy doesn't even have a clue what the product looks like, right? Whether it's going to have pistons or engines or whatever. Anyway, but he has to give an answer, so off he goes. He gives you an answer of 12 weeks, okay? And that's what we call planning a project, isn't it? And it's going to be late. I mean, we often do diagnostics and measurements of how often people launch their projects or finish their new product development projects on time, and quite often it is 0%, okay? So don't worry if yours is at 0%, it's quite often the case. 30% is pretty good, 50% is very good if your product's really finished on time. The first date you gave, right? Not the last date you gave in the last year before going to market, the first one. Anyway, according to the theory of constraint, you've already killed the project. Why? Because you are trying to, and this is true, this is why classical project management doesn't work. You're trying to force certainty on uncertainty, and you're twisting and torturing the system until it goes crazy, right? You have asked people to commit to durations in an uncertain world, right? We asked the person, how long will it take to prove a concept, right? He doesn't know that, right? So when we ask for commitment at the task level, the person, in fact, guesstimated how long it would take to do the job and added some safety, some buffer time, so that he would be able to honor his commitment, right? So what I've presented here is just a very simple representation of what's going on. Let's say that the blue stuff is the work to be done, and the white stuff there is the security or safety that I've added to the task durations, so that I can honor the commitment I gave to my boss when he asked me how long it would take to do that or that task. Okay, but this is not the way we actually do it. Have a look at the longer videos. We've assumed here that half the time is safety and half the time is work. Okay, that is not, I repeat, not the time. That's not the way we do it. Watch out, because that's one of the confusions that is out there about critical chain. We don't divide the times by 2, but it looks like it in this example. I agree. Once we've done that, what do? We take these blue durations, which are the focus durations. The focus duration is a duration that you think you will meet on average. It's not a commitment. So half the time you'll take more than that time, okay, in perfect working conditions with only that to do, a full kit of information, etc., etc. So it's very optimistic, isn't it? But that's what we have. We put those optimistic durations all together, and we have so 2 plus 8 plus 6 is 16 weeks, and we know that that's unrealistic because it's a sum of optimistic things. So we add a buffer, a big buffer of the order of 1/3 of the duration of the entire project at the end. Okay, so 16 divided by 2 is 8, and so we have an 8-week buffer. Okay, and that is how we plan the project. And please note already, it is scheduled, it is planned to go faster than the traditional planning. Okay, then we execute. The execution uses the iconic fever chart that you have here on the horizontal axis. It goes from 0 to 100%, which is the product being the project being done from its beginning at 0, to the end on the horizontal axis at 100%, right? So that's the 16 weeks, 2 plus 8 plus 6, horizontal axis. On the vertical axis, we have the buffer. The buffer is 8 weeks. That is how we present things and how we will monitor the project. When we execute it, we will see that as we go along and start doing the work, we start going slower than the optimistic durations that we had. So we start consuming the buffer. That's perfectly normal. Okay, and we just monitor it as you can see in this particular example to make sure that we're not consuming too much buffer, right? We're trying to stay in the green zone. Okay, I'll come back to that in a second. It's a bit more complicated than that, right? This is more of a slightly more detailed presentation of things. Okay, and so the more complete method of planning is to delete the individual margins, let's say the local safeties, and put them at the end as a global safety in the project buffer. Resource leveling, important. It means that we plan things with finite capacity. In this example you've got here, we only have one Peter, so Peter can only do one thing at a time. We take that into account and we plan it accordingly. Okay, so the critical chain here in red, okay, as it is identified, is very similar, close cousin to the critical path, except it takes also into account the availability of resources. Okay, and that is the critical chain, hence the name of the approach. And that sequence there is going to determine the duration of the project. Right, it is the constraint of the project, if you wish. Okay, and to ensure that that stays like that and it's stable like that, we make sure that the non-critical stuff, which is blue here, stays non-critical by protecting the critical path. Sorry, the critical chain. We protect the critical chain from any fluctuations that there might be in the non-critical blue stuff, and we do that by having feeding buffers so that they, their contribution to the project is done in such a way as that they will always honour the feeding or the connection with the critical chain, which is in red. Okay. Again, forgive me if it's going very fast, but that's the basic principle. And then we have these buffers. As you can see, two types of buffers in reality. The project buffer, which I've already talked about, and feeding buffers also to ensure that the non-critical stays non-critical. Okay. When we execute, another important point is what we call the relay race. Okay. Since the project will be the success or failure of the project will be determined by the way we do the sequence of red critical chain tasks. Okay. We imagine a baton like in a relay race to make sure that that sequence goes as well as possible. And in reality, what we do, we're not the only ones, in fact that's an idea we picked up in the book I mentioned earlier on. You can have a physical baton, or you can have a crazy object, and because of it's our sense of humour, our client's sense of humour, it's often a strange, remarkable object, such as you've got here for a recent project in Maine, USA, a pink lobster. It's also been a big pink pig or a panda or whatever, or it could be a rocket or a Batman or whatever. Something large and remarkable that goes from one desk to another, one office to another, so that everybody knows where the critical chain is. That is what's going to make the success or failure of the project. Keep out of the way. They don't have to go to stupid meetings and all that sort of stuff. It works really well. Okay. Again, as I finish off, this is the single project. We'll come to portfolios in a second. Okay. That's it. The colours there are completely empirical, right? What we're basically saying is once we've got the system set up properly, if we're in the green, we've got the uncertainty and variability and problems that we expected, right? We're in the noise, if you wish. If we're in the red, then we have more problems than we expected, and we're likely to be late, okay? And the orange between the two is just to say you're going between the two. The commitment that you might have given to the outside world, your client or your boss, is the top right-hand corner, right? And you aim to finish early, as you can see here. Just like when you take an aeroplane, right? You end up, if you don't want to miss your aeroplane, you make sure that you get to the boarding gate a certain amount of time before, 20 minutes, 2 hours or whatever, and so you don't miss your plane. It's the same thing in projects, isn't it? You should do that, okay? So that's the simple fever chart of the critical chain. And normally once you're setting this up correctly, you're getting your projects going faster than they were before, and you're finishing them all on time, and you've got excellent visibility. That's the secret sauce of single project critical chain. Okay, and so let's have a look at some case studies of single projects. Here, this is one where we did during the COVID-19 pandemic. Okay, so obviously at that time, every day, every hour was critical, life-saving, life-threatening, and so forth. What we were working on was multiplex testing. In this case here, we did other stuff, but this is multiplex testing, so fairly sophisticated machines, right? That would take a sample and be able to analyze. For this project we're looking at here, it would do 19 different pathogens, not just COVID-19, but into other stuff as well. So these diagnostics were being used by hospitals and stuff to monitor and treat COVID-19. Okay, so that was what the pilot project initially was. As you can see on the fever chart here, in the real world it can be kind of more crazy than what I presented, where in the school book example, going up and down and crazy. So that, that's what happens in the real world. You don't really always know exactly where you're going. So that's a nice little example of surprises one could have. Okay, we implemented critical chain. Lots of other stuff you'll see come back in many of the cases I'm going to present. We limited the work in progress, limited the number of different projects going on in the system, because very often that's what's killing efficiency, quality, productivity, and creating an unhealthy, stressful environment, is having too much work going on simultaneously in the same place and switching to bad multitasking, all that stuff. In this particular case, and I'll come back to it because it's at the moment it sounds like obvious, but it's important. Increasing the number of resources to parallelize certain critical activities and accelerate the development. When you could see, the critical chain, that's where we had to try and win some days, go faster. So can we add people at that stage and that stage to double up and go faster? Can we? We're in COVID-19, right? So we took some stuff to 2 shifts and so forth to try and go much faster. And just so you understand it, this conference is about critical chain, so I'm going to talk mostly about that, but in some ways I don't like to present things, like critical chain is the answer, what is your question? I don't like that at all. So you'll see that there's a lot of other stuff going on that's not pure critical chain. And for instance, in this case and in many of our implementations, we used Kanban boards to manage the day-to-day flow in parts of the system, right, for documentation and stuff. Okay, because that was the best way of doing it, rather than putting it into a scheduling system and managing it more formally. Okay, again on this project here, developing this medical device, 2 different exit points, because the same product was started as a development. Okay, and once they knew that they had something that worked well, it had to be validated and go to 2 different markets or 2 different regulatory bodies. In this example, the FDA and the European. Okay, so at one stage the work breakdown structure splits out, and you get 2 critical chains at the end if you're looking carefully, right? Which is unusual. It doesn't happen often, but here the project is cut into 1 critical chain goes to FDA, 1 critical chain goes to Europe. Okay, whereas the development of the product itself was done once and for all, wasn't it? Okay, it's just to show you some of the subtleties. That's fairly rare, but it does happen in this kind of environment quite often. Okay, so as I say, we had the fever charts, we had Kanban boards, and we had this used in various stages to monitor the project as a whole, and specifically some more critical parts such as the clinical trials and stuff, which again, it was in the pandemic, it was kind of difficult to know exactly how long a clinical trial was going to take, how many samples you'd collect, and all that sort of stuff. Okay, let's have a look at another example, another case study. This one is catheter-based minimally invasive solutions for heart surgeries. The demand was steadily increasing, and so they were having trouble avoiding the overheating. And so the initial situation was that there was a great problem with priorities. That's to say, a lot of stuff was late and therefore urgent, but you'd have many lists of priorities depending on the boss you spoke to, and basically everything was a priority. There was no staggering. That's to say, we do that and then that one, we stop that one, and all that sort of stuff. And I remind you, all the critical chain is part of the theory of constraints, and you'll see why and how in a second. So the theory of constraints says, if you have not managed to distribute your work equitably in your organization, so it's not because you've got 300 people in your company that they all have just the right amount of work, right? One person or one department has got the short straw, has got a lot more work than others. In this particular example, it was one person out of over 100 who was the capacity constraint of the new product development. And they thought, in fact, that their constraint was the new IT system that had been implemented to manage documentation and stuff, because it's true, it was going through teething problems and stuff, and everybody hated it and stuff. But that wasn't the capacity constraint, in fact. Okay, it was just one person who was, in fact, determining the output of over 100 people and the future of the company, right? Developing new products. Okay, no visibility on progress status. That's to say, even a week before the expected end date, nobody was really sure whether they were going to meet it, because they didn't have anything as powerful and simple as the critical chain, right? They had lots of reports saying all sorts of things, but they couldn't actually be sure the thing wouldn't happen when it would finish. What was critical, what was not, that wasn't clear for people. There were no project templates. That's quite frequent, right? Every new project, they tended to start again from zero or copy from some vague previous example. The handovers between the big departments, new product development, new product introduction and production, were not done properly under pressure. They just throw the stuff over into the next court, and as a result, the production teams had high scrap rates and had to finish the industrialization on the fly while they were producing, right? And this again is fairly standard. People were defeatist with regards to project management. As I say, you assumed that it was normal that, very rarely did they ever finish on time, because they assume, projects are like that. That's life. And critical chain says, no, that's not true. You can finish everything fast and on time. Okay, so the plan to implement critical chain was the project proper scheduling, the critical chain way of the projects, right? Identifying the critical chain and everything I tried to summarize. Making sure that the toll gates were more clearly adhered to and ensured that come back to full kit. That's to say, when you went past the toll gate in particular from new product introduction into production, production was capable of producing, that somebody had proven that they could produce it in good conditions before asking production to honour incoming orders. And in this particular example, as I said, what was strange was that just one person was the main initial bottleneck, and so that was identified as such, and found solutions around that to make sure that person was helped. Extra had assistance to be so they could produce more. It's quite easy to, when you've identified this kind of situation, right, that they can produce twice as much, 3 times as much. And by the way, normally that means that your entire organization can produce 50% more, 100% more, 150% more. Crazy numbers, yeah. That's the theory of constraints. And a robust prioritization system. I'll come to that in the last part, where we're looking at the portfolio fever chart, because that's the secret answer to that. Kanban boards, once again, to manage volumes of tasks to be done and understand what was going on. And we had to reconstruct the KPIs and the performance management systems, because they were not designed for success, right? As which you can get when you're doing things critical chain way. Right. Let's switch now to the portfolio dimension of the critical chain. This crazy trick of critical chain with regards to individual projects and portfolios is we claim that managing a portfolio of projects is very easy. Okay, we think that managing a portfolio of projects is very easy. Okay, because the necessary condition is just that all the individual projects in your portfolio are healthily planned and healthily executed with proper buffers to integrate the uncertainty that they have, and so that they are all planned to probably finish early, right? So when you have a bunch, when you have 30 healthy projects that are all likely to finish early, what's the problem? On the contrary, managing a portfolio, the PMO's job, is a lot easier than managing an individual project, because if, as will happen, one project has a lot more problems than expected, right, it goes into the red, you can call on the green projects that have less problems than expected and tell them, hey, stop for 2 months on that, please, and come and help this other project. So in this example here, you've got the portfolio fever chart. It is exactly the same as a individual project fever chart, except it is a concatenation of all your projects, okay, of your portfolio, and you just present them as dots, right? That's possible because everything's in percentages. It's not in days and weeks and months, right? It's in percentages, right? So you can have a big fast project and a slow project and whatever, all on the same chart with big buffers or small buffers. It doesn't matter. Everything's there, right? So your entire portfolio can be on a postcard. Your entire portfolio can be represented easily on a postcard, and you can absolutely understand what's going on in a blink of an eye, right? In 2 seconds, you know exactly what's the problem. The problem is what? P1 and P2, right? Full stop. right? It doesn't matter who's yelling what volume where, as often happens, right? And I hope that you'll all wake up somewhere between 2 o'clock and 3 o'clock in the morning tomorrow saying, I want one of these, right? This is fantastic, right? So how does it work? You just have the sum of all your different fever charts, right? And you have your meeting to decide what the priorities is. And in fact, it's the steepness of the slope, right? So the most important project which has the greatest difficulty is P1, and the second one, which is in trouble, is P2, right? So the first thing you decide is how to work on P1, right? Where are you working at the moment in your company? Are you not working, in fact, right up here, that's to say, on projects that should have come out 2 weeks ago, 2 months ago, right? You're firefighting at the end. I'm saying that what you need to be doing is turning out the fires that are born in your back, that are going to be your fires in 2 years' time, right? There's a problem here. Your marketing and your R&D has done something strange, right? That's not feasible. That's not realistic, or there's a problem there, or something strange is going on with P1, right? That's your priority, right? You should get to the stage where that's what you work on, right? That's like managers, right? And not firefighting out here where it's too late to do anything about it and you're not getting to any kind of root cause analysis and all that sort of stuff. So that's the beauty of managing a portfolio. Really easy with critical change. It does have a few necessary conditions, and I won't be able to go through them all in this short format. Here's one of them, okay? Now, just a clarity on vocabulary. There are two types of constraints when one is applying theory constraints to project management. One is that each critical chain of each project, right, that red sequence, is the constraint of that project, right? Each project has a constraint, and that will determine when you finish it, how fast you go, and so forth, right? That's one dimension. The other dimension of constraints in critical chain is that all these projects are going through your organization, and they're going through resources or departments and stuff, and one of those departments, for instance, is going to be overloaded compared to the others, right? It's going to have the short straw. It's going to have, as I tried to show with this series of tanks here with water flowing through them, there's a bottleneck somewhere, right, in one department, okay? And that is the other kind of constraint, the other dimension of constraints that you have when you're working the critical chain way in a portfolio, right? And that can be what? Well, it can be a department, it can be QA, it can be a person within that department with unique critical skills, or I say that because of my experience, it can be in the testing phase of your products, because that's quite often one of the things we find. Not so much in medical devices, but it does happen. Anyway, and then the rules are, once you've understood this, is don't flood the system. Keep things flowing, right? And to do that, you have to make sure that you only launch into your system what the constraints can manage, and you certainly don't launch work into the system just to keep everybody busy, right? Because they have excess capacity up there in whatever it is, proof of concept or marketing, whatever, right? They have excess capacity, and you don't want them to flood the system, because if you do that, everybody gets huge amount of projects at all stages, and they start multitasking between all of them, and priorities keep switching, and the whole thing goes mad, constipated, burnout, and all that sort of stuff, right? But one of the keys in portfolio management is, of course, not to pump into the system more projects than the system can cope with, okay? Maybe there'll be some questions about that, because it's a key important thing and something that most people get wrong, okay? Another example then, okay? So the diagnostic equipment for different types of diseases, respiratory and others, okay? So there are different kinds of projects in there when we enter the portfolio level. A completely new product, or an adaptation of a product, or modernization, new software to make it more, increase the sensitivity or whatever, new rules in new markets and whatever, all these sorts of things going on, okay? And of course there's quite a lot of interdependency between the different projects, right? I won't get into the subject of whether it's summer projects or programs or whatever, but anyway, there's lots of interconnections, okay? So you have to manage that complexity, okay, and so you have to see what's going on between the different populations, whether it's the scientists, the people doing clinical studies, regulatory, or whatever. Okay, that's the portfolio we're talking about here. To manage this, we have a two-level control system, okay, which is something we often do, or indeed can sometimes be a 3-level system. Where one which I've described is that each project has a plan, a critical chain plan, okay, but the portfolio was managed in a different way with a more synthetic, a simplified macro planning to be able to decide in this complex environment when I would launch this or that new project, and I'd be able to do simulations. What if, hey, if I launch that, what's going to happen to these other projects? Could I do maybe a minimum viable product of that first? Am I loading the resources correctly, or am I overloading them? Looking at all that sort of stuff. Okay, so there's quite a lot of work done here, and it's maybe for some of you maybe this is going to sound obvious, but what is important here is that all this becomes possible once you have accepted the idea that it is possible to plan this kind of work, right? You can have something which shows you the dependencies, shows you the resources, the workloads and whatever, and therefore then you accept to do some simulations and decide based on those simulations and decisions, right? So the critical chain should normally recreate a credibility of a plan in project environments, which frankly in most environments it's completely lost. That say nobody looks at the schedules and the plans anymore because they're not worth the paper they're printed on, right? So that's keeping it simple. What was going on, and a lot of work done to decide exactly what you're going to do with all the different options in the portfolio. Okay. And lastly, to finish, another case here. This one is in the south of France, hence the picture. It's one of the favourite locations of my team because it's a very nice place to go and work there on the Mediterranean coast. Anyway, this is a wonderful company with a huge market share, 70% in its business. And what's interesting here is they decided right from the beginning, because quite a few of our clients do it that way, that they would apply the critical chain not just to product development. Okay, they would apply it immediately to all major projects in their roadmap. Every large, complex thing that they had to be doing year by year, they would manage the critical chain way, right? So there was there was a change in regulation, MDX and so forth, that they had to adapt to. Okay, so that was quite a big chunk of work. There was some corporate transformations that were going on. They had some significant productivity improvements that required several stages. It wasn't just a simple little Kaizen event. It was complex and required to be managed as a project. Process changes where they were moving equipment, changing machines and that sort of stuff. Material changes when they're changing the raw materials in their products. IT, change of ERP, installing an MES, that sort of stuff. Anyway, all the large complex stuff was their portfolio. Okay, and that's what they did, and had fantastic results. What did it enable? Well, now that you've understood the logic, it was good. It enabled them to prioritize their projects, decide how many projects they're going to have. They had, quite often, I don't know why, organizations that kind of size, right, sort of between 400 and 800 people, have about 50, 60 different big projects to be done every year, which is much too much. Okay, so we argue and discuss the fact that they have to reduce the number of projects they're going to attempt to work on simultaneously, which will reduce the multitasking, enable at least the ones that they retain to go much faster, right? You probably have too many projects in your portfolio of this kind of thing, right, going on. You're being much too greedy, and as a result, nothing's coming out or nothing's finishing on time. So postponing projects, freezing them, whatever, and not only just purging it once, right, but learning to live that way. And some rule that people often end up adopting is, which we propose, is stop starting, start finishing. If somebody comes back, your marketing manager comes back from China and says, I got a new thing, we're going to make a fortune, etc. That's fine. But before we launch a new project into the system, we have to finish a project, right? So let's finish a project first, and then we can start this new one, right? We'll keep the number of projects in our system to 17 or whatever. Okay. And the ones that remain were planned with critical chain, with weekly updates on projects, on the portfolios, as I tried to explain. And just to finish off, a new dimension. Again, forgive me if in this short format I can't go into everything. So I want to add another dimension to what I've presented so far, which is a Pareto fever chart of project buffer consumption, right? We are expecting to consume buffers. That's what they're there for, okay? But there's a lot to be learned by watching why we're consuming buffer time, what was consuming that time, because that enables you to have a focused process of ongoing improvement, right? And in this example here, right, they started off initially, and after 4 months they noted down why they had wasted time on and consumed buffer, right? And this is typical what happens at the beginning. It's the major initial cause for wasting time was unplanned tasks. That's because their schedules were not very rigorously produced, right? Because they'd lost credibility, so nobody really worried about having very reliable, complete schedules, work breakdown structures, right? So somebody had to work on something that wasn't expected, and of course that consumed buffer, right? Unplanned tasks. At the beginning, it's often like that, but as you do that, and you find solutions, in this case, applying templates to your project management, so that you don't forget the tasks, right? You improve, and in this case, a little bit later, they cleaned up and they got to this other stage. And in that example there, right, so they're going faster, they're consuming less buffer, but the buffer that's being consumed in this example here on the right is a resource unavailable, a team member. In this particular example, it was one person, again, one person out of a team of 500, and this person was a fairly recent hire, about 3-4 years in the company, right? Had been hired initially to help with simple tasks in IT, feeding the paper to the photocopiers, helping people who had problems with their badge for the access to the buildings and the doors and stuff, and all this sort of very simple admin IT stuff. Okay, but that person was a very good hire and had been little by little being given more and more responsibilities without everybody really noticing. And when they looked at what was happening to their portfolio of their roadmap transformation of the company, right? This person was the person who was completely overloaded, and that they were the ones that were slowing down the execution of all these projects, right? The ERP, regulatory process changes, all that stuff. The common cause in there was one single person who was spending, when we did a dialo, we looked at what they were doing in their day, they were spending 30% of their time dealing with interruptions from people who'd lost their badge or couldn't get through a door and all that sort of stuff. In fact, that person had become invaluable to the company because she was really good at ERP, MES, Microsoft software and all this sort of stuff. She was the go-to person for all sorts of problems, including all these strategic problems. Anyway, so that was identified, the constraint. Off they went, and they lived happily ever after and went much faster and made a lot more money. Okay, that's it. To conclude, what are you waiting for to implement critical change project management? I've tried to explain what it looks like. Again, forgive me, I haven't spent enough time explaining the details. It's all there. You can watch the videos I mentioned, or you can sign up to the online training course and really get to grips with it. Okay, we've been doing this today. Is about medical devices, but we do it in all kinds of different product development environments. A lot of work in aerospace and IT for ERP implementations, in energy and maintaining aircraft and all these sorts of things, and pharmaceuticals, not just medical devices but pharmaceuticals, as you probably saw from the logos. And we do that all over the world, right? So that's what we're doing. If you're interested in seeing how it might apply to you, we have a reputation of being able to answer that question very quickly. We do a 2-day diagnostic if there are less than 500 of you on a site. And on the afternoon of the second day, we present the conclusions of our diagnostic about what we think your strengths and weaknesses are and how you could implement the theory of constraints. We do that once a week somewhere in the world, and everybody loves it. Okay. Ideally, we finish those after those 2 days. We add a third day, which is a 1-day training course on critical chain, so that people understand what critical chain is. We sell critical chain to people. We explain critical chain by explaining how it works. It's not complicated. In 4 hours, you can do it. And certainly in 8 hours, everybody understands what the approach is and why it works. And it's not so complicated. Some people say it's just common sense, right? And of course, we adapt what we do to the different environment, large company, small company, and as I said right in the introduction, medical devices goes from very complex things to very simple things. So you need to adapt it to exactly what's going on. So that's it. Thank you very much.